Hello guys, welcome back again. My name is Amit and it's code time. So we are finally back again after quite a time. So in previous 1 month I was actually busy in some kind of work and also some kind of health issues, so I wasn't able to make any video. But not a problem. Here we are again. So today we'll be continuing our maths and array series, and today we'll be talking about one of the most important topics and one of the most basic algorithms that we start with in data structures and algorithms, and that is cadence algorithm. And cadence algorithm is basically used for finding maximum sums of array. So that is basically the most basic use case of the cadence algorithm. But it can be extended to various other scenarios and various other problems. And from the point of view of interviews, nowadays it's not very frequent, but still it's helpful and it might be a part of any other question. I mean, while finding a solution for some problem, you might end up recognizing the algorithm is being used in some or the other way. So that's why the knowledge of this algorithm is very important. Okay, and it is also important that it can be asked in interviews. Okay, and as also from the point of view of computer programming, in a lot of questions you might end up using this algorithm. That's why it's very important. So without wasting any time, let's directly jump into it. Okay, so today we'll be talking about cadence algorithm. So let's start with it. So cadence algorithm. Okay, so basically, the idea behind cadence algorithm is very simple, very basic, and it's like just common logic, like common sense. It's not very difficult. So basically, it's typically used for maximum subarray sum problem. So you will hear this problem a lot. Maximum sum subarray. So basically, you are given an array where you can have positive and negative integers both, and you need to find the maximum sum of a subarray that is possible, right? So basically, you are like given an array. So like you have an array, okay? Pardon my drawing. It's not very elegant, but still okay. So let's say we have an array like this, okay, and we take samples like 8, -2, 3, -10, 6, 5, and -9. Okay, so we need to find the maximum subarraysum that is possible. Okay, so here we can see if we start with this subarray. So basically, this is 8. This is 8 plus -2 is what? -6. Okay, and if we not -6 plus 6. Okay, if we continue the subarray, we'll get what? 11, right? Then if we go to this, we'll get 1. Then 1 plus 6 is 7. Okay, then 7 plus 5 is what? 12. So if we take this subarray, okay, so what sum do we get? We get 8 minus 2, 6. 6 plus 3, 9. 9 minus 10 is what? Okay, this was uh, okay, this was 9 minus 3, 9, 9 minus 3 was -1, right? Okay, so -1 plus 6 is what? Then 5, 5 plus 5 is 10, right? So for this subarray, we get a sum as 10, right? So basically, this is a subarray, and we need to find the sum of various subarrays that are possible. And among all those sums of subarrays, we need to find the maximum sum possible, right? So if you take this subarray, so how many elements we have? We have 1, 2, 3, 4, 5, 6, 7. So basically, we have how many subarrays possible? 7 into 6 by 2, basically mean 21 subarrays, right? We have 21 subarrays possible, right? And if you go on and try to find the maximum sum of a subarray, then basically you need to check all these 21 subarrays, and that is basically the overview of the problem, right? So what's the naive approach of solving this problem? So if we go by the naive solution, so what is the naive solution? The naive solution is basically finding all subarrays. So naive solution says run two loops, run two loops and find all subarrays, right? Find all subarrays. So basically, you just run two loops, one outer loop for I and the inner loop for j, and you basically calculate the sum of every subarray possible. But what is the time complexity of the solution? It's order n square, right? It's order n square. Okay. And space complexity is order 1. Space complexity is okay. We can see we do not need to store these sums in any array. We can directly initially take a variable that keeps the track of the maximum sum, right? Okay. But still, it's order n square. Let's say your n was around 10 to the power of 5. Okay, nearly 10 to the power of 5. Will this algorithm work? This algorithm won't work, right? Because if order n square is present, it's 10 to the power of 10 and it will easily give you a 10, right? So this means that this is not a very optimal approach when the value of n is big, right? If let's say n was around 100 or 1000, this solution would work. Okay, it can pass easily because the constraints are not very hard. But when the value goes bigger than 10 to the power of 3, I mean around 10,000 or 10 to the power of 5 or 10 to the power of 6, you cannot use this solution, right? Because you'll get a DLE. So then what do we do? What is the best way to find the maximum sum subarray or the maximum sum possible of a subarray in a better runtime? Okay, here comes our cadence algorithm. So cadence algorithm is based actually on a very simple logic. Okay, What is that basic logic? Let's say you had a subarray. Let's say you had a subarray, and the sum of the subarray was, let's say, S1. Okay. So basically, this was a subarray, and the sum of the subarray was S1. Okay. Then let's suppose we have another small subarray or whatever it is. Okay, we have another subarray, and the sum of this subarray is S2. Okay. And then we have some elements from here onwards, like a let's say AK plus 1 and onwards, right? Like let's say we have this kind of situation where we have the sum of a subarray from S1, then we have sum of another subarray S2, and then we have elements from here onwards going on. So we basically have three segments. Okay. At this point of time, just consider on three segments. Okay. Okay. So let's say S1 was greater than 0. Okay. S1 was greater than equal to 0. Okay. And let's say S2 was less than equal to 0. Okay. So basically S1 was positive and S2 was negative. And then here onwards we have positive elements. Okay. Let's suppose that AK is greater than 0, or whatever these elements can either be greater than, or they can also be less than 0. Okay. So whatever it is, we do not need to focus on this part. Okay. Just focus on these two segments. These two segments are very important. Okay. Let's say if S1 was bigger than S2, so basically we are not talking about sign terms. Okay, let's say S1 was 5 and S2 was minus 6. Okay, so basically we are not talking about this 5 value being greater than minus 6. Okay, we are considering this independent of sign. Okay, so basically we are considering the ABS value of both these things. Okay, we are basically considering the ABS values of both these things, absolute value. Okay. So if absolute value of S1 is greater than absolute value of S2, this means S1 plus S2 would also be greater than equal to 0, right? Okay. So basically, if the absolute value of S1, that is positive, is bigger than the absolute value of S2, which is negative, then basically their actual summation would also be bigger than equal to 0, right? So this means if we have a subarray that has a sum S1 and we have a subarray S2 which has a sum negative, we can actually extend this subarray further. Okay, that is basically the core idea of cadence algorithm. If you have a subarray S1 which has a sum S1 which is positive, and then you have a negative subarray S2 which has a sum which has a negative sum, and if S1 plus S2 is basically bigger than 0 or greater than equal to 0, this means that there is a possibility to extend this subarray, this S1, further onwards, because since this sum is bigger than 0, it is possible that this sum can increase the further elements, right? सिंपल सी बात है, सिंपल सी बात है। अगर ये एलिमेंट, अगर ये सम अगर इन दोनों का सम S1 प्लस S2 अगर पॉजिटिव आता है, इसका मतलब क्या है कि वी कैन इंक्रीज द फर्दर सम, राइट? क्या पता AK और AK प्लस 1 के ऑनवर्ड्स ये अगर पॉजिटिव एलिमेंट्स हैं, तो सिंपल सी बात है, अगर हम S2 को देख के अगर इसको इग्नोर मार दें, अगर हम क्या करें कि S2 है नेगेटिव है तो इसको ड्रॉप कर दें, तो इट वुड नॉट बी जस्टिफाइड। क्यों? ऐसा भी हो सकता है, क्या पता S1 का कोई कंपोनेंट जो हो वो बच जाए। लेट्स से अगर S1 प्लस S2 अगर बिगर देन 0 है, इसका मतलब कुछ पॉजिटिव सम रह जाएगा जो कि फर्दर एड ऑन हो सकता है इस वाले सेगमेंट में, करेक्ट? So that's why that is what we do. अगर इन दोनों का सम अगर it's positive, अगर it's greater than equal to 0, we can extend this S1 sub array. That's basically the first case, जो कि नॉर्मल है, सिंपल सी बात है, that is very normal. Okay, जो कि हम केडेंस में यूज करते हैं. Then there is second case. Second case सिंपल सी बात है, जस्ट इसका इनवर्स होगा. What is if S1 plus S2 is less than 0? अगर S1 plus S2 less than 0 है, what do you think? Is it optimal to extend this sub array? अगर इसका सम और इसका सम, इन दोनों का सम जो है वो नेगेटिव आ रहा है, दैट इज लेस देन 0, इज इट ऑप्टिमल टू एक्सटेंड दिस सम फर्दर? नहीं ना। क्यों? बिकॉज सिंस दिस सम इज नेगेटिव, कि आगे चल के जो एलिमेंट्स है ना उनको घटाएगा, राइट? लेट्स टेक एन एग्जांपल, लेट्स से S1 वाज, लेट्स से S1 S2 एंड देन देयर वाज लेट्स AK plus 1, इतने दो एलिमेंट इतने लेते हैं. ओके, लेट्स सी वी हैव एलिमेंट्स लाइक व्हाट, this was 8, this was minus 6, this was 2, and this was 3. Okay, so now here we can see 8 minus 6 is what? 2. So 8 plus minus 6 is what? 2. And if we extend this subarray, we can see कि 2 plus 2 what? 4, 4 plus 3 7. So basically अगर हम इतने subarray को लेते तो हमारे पास सम क्या आता? 5 आता. But just because ये S1 plus S2 के segment का जो sum है, that is positive, that's why we were able to extend this segment further. And here we can see, because of this S1 plus S2 bigger than 0, we can add this 2 to 5 and we can get a maximum sum of 7. अगर हम इस complete array को ले लें, इस complete sub array को ले लें, तो what do we get? We get 8 plus minus 6 2, 2 plus 2 is 4, 4 plus 3 7. So that's why हम अगर ऐसा केस आता है जहां पर S1 plus S2 is greater than 0, we extend the sub array, right? अब एक second case लेते हैं. Second case क्या है? When let's say this was 8 and this was minus 10 and we had 2 and we had 3. अब क्या होता है, अगर हम इसको अकेले कंसिडर करें तो 8 है, वेरी गुड. अगर इन दोनों को साथ में कंसिडर करें, वी गेट 5. ओके, अब देखते हैं, इफ वी ऐड 8 टू minus 10, व्हाट डू वी गेट? वी गेट -2. इफ वी ऐड -2 to 5, will it decrease the sum or increase the sum? सिंपल सी बात है, इट विल डिक्रीज द सम। तो दैट्स व्हाई वी शुड नॉट एक्सटेंड दिस सबैरे फर्दर। यही रीजन है, मेरे कोर आइडिया है कि अगर किसी सेगमेंट का जो सम है वो नेगेटिव आ रहा है, टोटल सम नेगेटिव आ रहा है, S1 प्लस S2 नेगेटिव आ रहा है, दिस मींस कि उस सबैरे को या फिर उस सेगमेंट को फर्दर एक्सटेंड करने का फायदा नहीं है, बिकॉज इट विल ओनली डिक्रीज योर सम, राइट? वो आपका सम हमेशा घटाएगा ही। दैट्स व्हाई व्हाट डू वी डू, व्हेनेवर वी गेट S1 प्लस S2 लेस देन 0, वी इमीडिएटली वी इमीडिएटली इग्नोर दिस प्रीवियस सेगमेंट और हम एक फ्रेश स्टार्ट कर देते हैं। हम कहते हैं कि अगर इस सेगमेंट का सम कंप्लीटली नेगेटिव आ रहा है, तो दिस मींस कि इसको एक्सटेंड करने का फायदा नहीं है, एंड मेक अ फ्रेश स्टार्ट एंड स्टार्ट कैलकुलेटिंग द सम ऑफ दिस सब एरे। ठीक है, एंड दैट इज बेसिकली द आइडिया, कंप्लीट आइडिया ऑफ केडेंस एल्गोरिथम। क्या करना है, अगर सिंपल दो कंडीशन है, इफ S1 प्लस S2 ग्रेटर देन इक्वल टू 0, एक्सटेंड द सेगमेंट, ओके, एंड इफ S1 plus S2 is less than 0, then stop or end the segment here, make a fresh start, make a fresh start। और ये fresh start कैसे होगा, सिंपल सी बात है, you can make your sum variable to 0। आप अपने सम वेरिएबल को दोबारा 0 से इक्वेट कर सकते हो और आपका काम हो जाएगा, राइट? अब एक बार इसको एक ड्राई रन करके देखते हैं। ड्राई रन ऑलरेडी हम वैसे कर चुके हैं, आई मीन दिस वाज फाइन इनफ, बट स्टिल हम इनिशियल जो हमारा ये था, एरे था, 8 माइनस 2 3 माइनस 10 6 5 माइनस 9, इसको भी लेके देख लेते हैं, राइट? So we had values what? We had values 8, I think 8 what? 8 minus 2, 8 minus 2, then 3, then I think minus 6 or minus 10. Minus 10, 6, 5, minus 9. So this was minus 10, 6, 5 and minus 9. Okay. So let's start. Let's see. So currently we had our sum as what? 0. Okay. And we'll maintain basically two variables, the current maximum and the current sum. So basically, let's take these, I'll define these variables as what? Uh, sum is 0 and max sum is also 0. Initially both of them are 0. Okay, so then we basically add our sum. So I'll just write them down like this so that we are not confused. Okay, so now basically we add 8 to sum, so basically sum becomes 8. Now we compare if the sum is bigger than maximum sum, so we can see 8 is bigger than 0, so basically we update our maximum sum. Very good. Then we add minus 2 to sum. So basically 8 minus 2 is what? 6. Is 6 less than 0? We can see कि currently हमारे segment का sum अभी भी greater than equal to 0 है. So therefore हमारे पास अभी भी क्या है, होप है कि we can extend this segment. And is 6 bigger than 8? No, it's not. So हमारा maximum sum 8 ही रहेगा. Okay. Then we go to 6 plus 3 is what? 9. So we can see कि हमारा sum update हो गया. We can see कि extend करने की वजह से हमको फायदा मिला, right? So our new sum becomes 9. Is 9 bigger than maximum sum? 8. Yes, it is bigger than. So we get our 9. Okay. Then we have 9 minus 10. 9 minus 10 is what? 9 minus 10 is minus 1. So here we can see the sum has gone down less than 0. इसका मतलब इस सेगमेंट को आगे बढ़ाने का मतलब नहीं है। वी शुड ड्रॉप आर आइडिया, वी शुड कंप्लीटली ड्रॉप द आइडिया। सो सिंपल सी बात है, हम क्या करेंगे, वील अगेन मेक आर सम बैक टू 0। हम इसको रीइनिशियलाइज कर देंगे 0 से, मीनिंग दैट फ्रॉम नाउ ऑनवर्ड्स वील ड्रॉप द सेगमेंट एंड वील जस्ट लुक एट दिस सेगमेंट ऑनवर्ड्स, राइट? और क्योंकि हमारा सिंपल सी बात है, अब सम 0 हो चुका है, तो हमारा मैक्सिमम सम 80 रहे 9 रहेगा, राइट? ये अपडेट नहीं होगा। Now, sum is now 0. 0 plus 6 is what? It's 6. And it's not bigger than 9. So maximum sum is still 9. Now 6 plus 5 is what? 11. 11. Is 11 bigger than 9? Yes, 11 is bigger than 9. So therefore we update our maximum sum. We get as 11. Then we had 11 minus 9. So 11 minus 9 is what? 2. So since again our sum is what? Our sum is greater than equal to 0. Therefore there is a possibility that we can extend this subarray. Okay, अगर यहाँ पर और elements होते तो we would have extended the subarray, but not the problem. हमारा sum हो जाता है 2, and since 2 is not bigger than what? Not bigger than 11. Our maximum sum becomes 11. So therefore by the end of the complete iteration, after traversing the complete array, we can see our maximum sum possible is what? 11. And if you try out any possible subarray that is possible, अब जितने भी subarray possible उन सबका sum निकाल के देख लो, 11 would always be the maximum sum possible, जो कि क्या होगा, जो कि इस segment का sum है, which is the sum of these two elements, this segment, right? So that is basically how योर केडेंस एल्गोरिथम वर्क्स। अब सिंपल सी बात है, हम अपने एरे पे सिर्फ एक बार ट्रैवर्स कर रहे हैं, राइट? हमने कोई भी फालतू का सब एरे बार बार नहीं बनाया। वी वर्क वेरी ग्रीडीली। रिमेंबर दिस, केडेंस एल्गोरिथम इज एक्चुअली ग्रीडी एल्गोरिथम, राइट? क्योंकि वो ऑप्टिमैलिटी पे ऐसे काम करता है बिकॉज इट लुक्स एट द सम ऑफ द सेगमेंट्स, कि हम अपने सम के सेगमेंट के सम को एक्सटेंड कर सकते हैं कि नहीं कर सकते हैं, राइट? इट लुक्स एट दैट, सो दैट्स व्हाई इट्स ग्रीडी एंड दैट्स व्हाई इट्स आल्सो ऑप्टिमल, इट वर्क्स फाइन। Okay, so since we are only covering every element only one time and traversing the complete array only one time, so the time complexity from n square goes down to order n, and since हमने कोई एक्स्ट्रा एरे भी नहीं बनाया है, द स्पेस कॉम्प्लेक्सिटी स्टिल रिमेन्स ऑर्डर 1, एंड दिस इज वन ऑफ द बेस्ट एल्गोरिथम्स दैट यू कैन फाइंड फॉर सॉल्विंग दिस प्रॉब्लम. सो हम सिंपल से क्वाड्रेटिक से सीधे लीनियर रन टाइम पे आ गए, राइट? वी डायरेक्टली वेंट टू लीनियर रन टाइम, एंड दैट इज बेसिकली हाउ द केडेंस एल्गोरिथम वर्क्स. एंड आप इसके बहुत सारे वेरिएशंस देखोगे. इट कैन बी पॉसिबल कि आपको बोला जाए कि मैक्स की नेगेटिव सारे नेगेटिव हो. अगर ऐसा इनकेस आ जाए कि सारे एलिमेंट्स नेगेटिव है, उस केस में ऐसा होता है कि यू माइट आइदर रिटर्न द आंसर एज जीरो, और योर आंसर माइट बी इक्वल टू द वट एवर इज द मैक्सिमम नेगेटिव वैल्यू. मैक्सिमम नेगेटिव बेसिकली मतलब कि जो सबसे कम नेगेटिव है, जैसे -6, -5, -2, -3 है, तो -2 विल बिकम योर आंसर. सो देयर आर अ लॉट ऑफ वेरिएशंस. देन देयर आर आल्सो प्रॉब्लम्स वेयर यू नीड टू फाइंड द मैक्सिमम प्रोडक्ट ऑफ अ सब एरे. ठीक है, उस क्वेश्चन में भी केडेंस का मॉडिफाइड वर्जन लग जाता है. ओके, सो दिस बेसिकली हाउ केडेंस एल्गोरिथम वर्क्स. So I think core idea is very clear. Okay, remember these two things. Just focus on these 2 points. इस इन दो पॉइंट्स इन दो केस से पूरा cadence algorithm कवर हो जाता है, right? Now let's move to the implementation part, and let's look at how it is implemented. Okay, so let's start coding our approach. So first of all, let's include our standard libraries using namespace std and then in main. And since it might be possible that you get a lot of uh, big numbers, so that's why it is always to be on the safe side. You can always try to go for the you know finding the taking long, right? So let's first of all take value of n. C is n, that you get the size of the subarray. Then basically we'll declare a long subarray. Okay, and now let's take the input auto and it. See, it. So from here onwards, we have taken our input. So now we'll be basically focusing on finding our answer. So first of all, we'll take two variables. First of all, that is current maximum. Okay, and then we have sum. Okay, or let's change these variables. Let's take this as maximum. Okay, just in order to clear out the confusion. So here in this question we have assumed that, let's say, if all the numbers are negative, then our maximum sum possible is basically zero. Okay, this means that empty सवारे हम ले रहे हैं. That might be not applicable in a lot of questions. कुछ क्वेश्चन पे वो बोलेंगे कि you need to find the कि अगर सारे नंबर्स नेगेटिव है तो सबसे कम नेगेटिव नंबर जो है उसको रिटर्न करा दो. उसके लिए कुछ नहीं करना है. उसके लिए जो मैक्सिमम सम की वैल्यू है उसको आप इंट से रिप्लेस कर सकते हो. ओके, यहाँ पर हमने जीरो लिख रखा है. आप इंट से रिप्लेस कर दोगे तो दिस विल आल्सो हैंडल इन केस इफ द कंप्लीट एरे इज फिल्ड विद नेगेटिव नंबर्स. ओके, सो ऐसा करता हूँ मैं, इसको इंट से ही इक्वल कर देता हूँ. ओके, सिंपल सी बात है, वो काम कर ही जाएगा. ओके, सो नाउ वी स्टार्ट बेसिकली आवर कोड. सो व्हाट वी डू फॉर int I equal to 0, I less than n, I plus plus. Okay, I don't know. Okay, then what we do sum plus equal to a of I, and then if we check if sum is bigger than maximum sum. Okay, if sum is bigger than maximum sum, then what do? We basically update our maximum sum, right? So our maximum sum becomes equal to sum. Okay, nice. Okay, so this was basically finding the maximum sum. Now what do if our sum is less than zero? So here is the condition. What do basically whenever your sum, जो आपका सेगमेंट का सम है वो लेस देन जीरो हो गया, तो आप क्या करोगे? आप तुरंत अपने सेगमेंट के सम को इक्वल कर दोगे जीरो से. ओके, इट विल कंप्लीटली बिकम इक्वल टू जीरो. ठीक है, ये आपका यहाँ पर कंप्लीट हो चुका है. दिस इज द कंप्लीट केडेंस एल्गोरिथम. सबसे पहले आपने क्या किया? सिंपल सी बात है, अगर आपके सम का सेगमेंट बढ़ता जा रहा है, इफ इट इज ग्रेटर देन मैक्सिमम सम, सो यू विल अपडेट द मैक्सिमम सम. In any case, when your sum becomes less than zero, that is आपका सेगमेंट का सम जो है वो नेगेटिव हो गया है. दिस मीन्स दैट देयर इज नो यूज टू एक्सटेंड दिस सेगमेंट. सो देयरफॉर हम उस सेगमेंट को जीरो कर देंगे, उसका सम जीरो कर देंगे, एंड वी मेक अ फ्रेश स्टार्ट फ्रॉम जो भी बचा हुआ वैल्यूज है. ओके, सो नाउ व्हाट डू वी प्रिंट? वी प्रिंट सी आउट maximum sum of a subarray. Okay, it will be equal to maximum sum. Then return 0. I hope everything is visible. Hmm. So this is basically the complete code, and this actually just this part is the code of cadence algorithm. Now let's try to run this piece of code. All right. So g++ cadence. Okay. Dot slash k.exe. Okay, so let's take the same test case that we took. So I think we had what? We had six numbers. We had 8. Then we had what? -6. Then we had we had 2. We had 2. Then we had 6. Then we had -10, I think. Then we had 2. Then 3. Then -9. Right? Okay, we had 7 numbers. Right? Okay. Okay. Okay, let me just rewrite this thing again. Okay, so we had 7 numbers, we had 8, then we had -2, then we had 6, then we had -10, then we had uh, 2, 3, and -9. Okay, are the values changed? Okay, let me just check. It was 2, 3. Okay. Okay, I had taken two. Okay. Let me just change these values. It should not have been 6. Okay. Okay. Let's nevertheless, if you try out the sample, if you try to sum it up, what do we get? We get 8. 8 minus 2 is what? 6. 6 plus 6 is 12. 12 minus 10 is still 2. Then 2 plus 2 is basically 4. 4 plus 3 is 7. Okay. So this is not the optimal thing. Okay. Let me check. Okay. 8 minus 2 is what? 6. 6 plus 6 is 12. 12 minus 10 is 2. Okay. How do we get the maximum sum as 12? Is it right? Okay, yeah. So since 8 minus 2, 6, 6 plus 6, 12. So that is why the answer is 12, right? So that is basically the maximum sum. Let's try this thing again. 7, then we had 8 minus 2, and then we had what? 3, then we had minus 10, then we had 2, 3, and minus 9. Okay, it's 9. Okay, so we have 9 in this case. So 8 minus 2 is 6, 6 plus 3 is 9. Okay, am I changing the thing? Okay, it's 8 minus 2, 3 minus 10, 6, 5 minus 9. Okay. Okay, 7, 8, then we had minus 2, then we had 3, then we had minus 10, then we had 6, then we had 5, then minus 9. Okay, so here you can see that we are getting our answer as 11. That is optimal. That is 6 plus 5 is 11, right? So that is basically how cadence algorithms work. You can also use the same algorithm to find the subarray. That is basically getting. So basically, what you can do is, so basically we take four variables. Start is minus one, end is also minus one, and then we also take two normal variables s equal to minus one and e is also equal to minus one. This will be basically used to mark our start and end indexes. So what do we do? If max sum is bigger than this, then start is basically equal to s and end is equal to e. Okay, so basically you mark the starting and the ending indexes. Okay, else what you do? If sum is equal to 0, okay, whenever basically you start, let's take you basically take this thing as 0. Okay, you basically take this thing as what? 0, right? And ending is always made equal to I. So that is basically for updating the max, the best start and ending. So whenever you get a sum that is less than 0, and where you are updating the sum equal to 0, this means that you are going to start a fresh segment from onwards, right? From there onwards, you're going to start the fresh segment. So what do? You will basically make s equal to what? I plus 1, right? Because currently you are at ith index, so basically you need to go for the what? For the next possible value, right? And from here, you can just take e is equal to I, because whatever it is, it's currently the ith index. Okay, in this case, I think you can make both of them as e equal to I plus 1. Okay, and I think here you can make this equal to I. I think this would be fine enough. Okay, now let's try to run this piece of code. Before that, start index basically start and index is end. Now let's try to run this piece of code and check. Take 7, we take 8, take minus 2, then we take 3, then we take minus 10, then we take 5, 6, and minus 9. Okay, so here we can see that the maximum sub array is possible sum is what? 0, 1, 2, 3, and 4 and 5. So we can see that if we start at index 4 and end at index 5, so basically these two elements will get you the maximum possible sub array sum, and that is of 11, right? And you can try out other values as well. Okay, you can go ahead and let's take some other examples too. Let's take previous example that we took by mistake, like 8 minus 2, then 6, then minus 10, then 5, then 6, not yeah, 5, 6 minus 9. Okay, so here we can see if we take 0 to 5, 0 to 5 is basically what? This up to I think 0, 1, 2, 2, 3, 4, and 5. Okay, if we take the sum of this complete subarray, what do we get? We get what? 8 minus 2 is 6, 6 plus 2 is 12, 12 minus 10 is 2, 2 plus 5 is what? 7, 7 plus 6 is 13. So we can see if we take this complete subarray, we get the maximum sum possible, right? And that is how basically you can also calculate the exact subarray which gives you the maximum sum. So I think that covers up complete cadence algorithm along with the code part. So I hope that you understood how cadence algorithm works. And that's all for today, guys. Make sure to drop a like, hit the like button, subscribe to the channel. Most of the people who are visiting the channel do not watch the video till the end. So it's my humble request, because on the previous video, which was basically on a sieve, segmented sieve, it did not quite pass the barrier. The number of views and what I was expecting, the response I was expecting was not up to the mark. And so I humbly request to everyone that you watch the videos till the end. give your comments, give your suggestions in the comment box so that I can also get a feedback that what where I can improve, what I can add, what I should remove, right? And that is all for today, guys. And we'll meet again with another topic in the next video. Till then, bye bye, guys. Keep grinding.